Okay, Chapter 2, Derived Units. This is where we take units and stick them together. After all, when we say something like, how fast were you going? If I said I was going 4,715 centimeters per minute, would you think I was going really fast or really slow or what? Well, I don't really know because I don't think of speed in terms of centimeters per minute, but I do think of speed in terms of miles per hour. This is why you might want to do this kind of conversion. Same with each of these. For this one, feet squared, square footage is really important with buying a house. So if I had a house that was this big in kilometers squared, would that be a great big house or a little house? I don't know. I'd have to convert it to feet squared to know. And then this looks like an awful problem, but it turns out it's a real simple one if you just take care of things one unit at a time. And that all comes back to using your road maps, canceling your units in each step, using conversion factors, and then being careful with your sig figs at the end. Okay, so why don't you write down these problems, write them out every step of the way to get to the right answer, and how you think about it. Be careful with sig figs and units, see what you get. Then after you come back from the pause, we'll check and see if your answers are the same as mine. Alright? Pause. Alrighty, we're back. Let's go. Let's get started. Well, when I think of miles per hour, I think of miles on top and hours on the bottom. So your job is to take the centimeters part and go to miles, because nowhere on your conversion sheet are you going to see centimeters per minute and miles per hour conversion. It's up to you to know that this is a distance and this is a time, and you know that it's a one-step conversion to get from minutes to hours, and this is a metric to English, so if you can go centimeters to inches and inches to feet, you can get to miles. So it ends up being 1, 2, 3, 4 conversion factors, and your job is to just be careful and make sure you take care of the units one step at a time. Okay. Start with our original number. I like running the units with a clear numerator, clear denominator, so that I can keep track of what's going on with each. Take care of one at a time, and it doesn't matter which one to do first. We'll do the numerator first. If we want to get centimeters to inches, clearly centimeters has to be on the bottom, inches on top. Let the centimeters cancel. Where do I find that conversion? Aha! Length. Let's see if you can see it here without the light. 2.54 centimeters is equal to 1 inch, exact by definition. Okay, good. So 2.54 centimeters per every 1 inch, and that's an exact conversion factor. Alright, what's next? We're at inches, we go to feet. That's inches on the bottom, feet on top, inches cancel. And I think we all know there's 12 inches per 1 foot, and that's an exact conversion factor. Now we've converted to feet, now we can get from feet to miles. And how do we go about doing that? Feet on the bottom, miles on top, right? 5,280 feet per every 1 mile. Ooh, I forget how many feet per mile. Don't worry. It's staring at you right in the face on your conversion sheet that you'll have on every exam. Feet cancel. We're left with miles on the top. We wanted miles on the top. Miles per hour. That's great. We're almost done. Now we've got minutes on the bottom. Minutes in the denominator. We need to end up with hours in the denominator. How do we take care of that? Well, if minutes is in the bottom, to get it to cancel, we have to put minutes on top, because minutes divided by minutes is 1. That's why the hours ends up being on the bottom, and you know there's 60 minutes in 1 hour. Okay, so let's, having done our unit analysis, where are we? That's 1 times 1 times 1 times miles times minutes, which is miles. And in the denominator, 1 times 1 times 1 times 1 times hours. So that miles per hour. Great. That's exactly what we want. Okay. So now we just deal with conversion factors and units. Well, this is also English to English and English to English, so those are all infinite, which means 4 sig figs is my original number, 4 in my answer, and if we write that number to 4 sig figs, we get 1.758 miles per hour. Is that what you got? We're walking real fast. Seemed like we were going fast, but we really weren't. Alright, I'm going to show you 2 ways of doing the next problem. The key here is that if you're going to square a conversion factor, you have to square every part of what's inside the conversion factor. You'll see what I mean. Kilometers is a distance, feet is a distance. This is metric, this is English, so we have to do that metric to English conversion at some point. Can you get from kilometers to centimeters? Well, yeah, if you go to meters first. Okay, kilometers to meters squared, meters squared to centimeters squared, centimeters squared to inches squared to feet squared. Alright, so let's get started. 3.210 times 10 to the minus 6 kilometers squared. Remember, that's the value. 3.210 times 10 to the minus 6. That's the unit, kilometers squared. We're not squaring everything, we're only squaring the unit. So, kilometers to meters, that means kilometers on the bottom, meters on top. And there's 1,000 meters per 1 kilometer, but we need to square that. And when we square that, we square the 1,000 and the meters and the 1 and the kilometers, and that allows us to cancel out the kilometer squared. Alright? So now that we're at meter squared, we want to go to centimeter squared. Meters on the bottom, centimeters on top. If we square everything, there's 100 centimeters in 1 meter. That means we square the 100 and the centimeters and the 1 and the meters. That allows us to cancel out the meters squared. Good? And taking care of that by squaring everything. Centimeters to inches. This time centimeters is on the bottom, inches also on the top. There's 2.54 centimeters per every 1 inch. But we have to square that, which means we square this and the inches and the 2.54 and the centimeters, which allows us to cancel out the centimeter squared. Once we're at inches squared, we can get to feet squared. 12 inches per every 1 foot, but we're squaring every part of the conversion factor. That allows us to cancel out the inches squared. The only units that are left are square feet. Conversion factors say that's infinite. That's infinite. It's metric to metric, so it's infinite. Metric to metric, so it's infinite, which means 4 sig figs are my answer. Alright, so let's punch all this in our calculator. Be careful. Know how you're doing and entering things. 3.210 times 10 to the second function EE for this calculator, minus 6. Okay, that's the original number. Now we're going to multiply by 1,000 and then multiply by 1,000. That's what squaring 1,000 is. We're going to multiply by 100 and multiply by 100. And we're going to divide by 2.54 and divide by 2.54. And we're going to divide by 12 and divide by 12 to get my final answer of 34.55 square feet. 34.55 square feet is just a tiny little room, basically. It's not, well, actually, it's actually a big room, but a very small dorm room. Okay, so there you go. Not too bad if you follow step by step. Now, why do we have to square? Because if you thought about your units here of kilometers squared as kilometers times kilometers, okay? Well, how would you go about canceling each one of these to turn it into meters? Well, you'd do 1,000 meters per every 1 kilometer. But wouldn't you have to do that twice? Sure you would. Isn't that the same as this? Yeah, and then you do this twice to cancel out both of the meters. And you'd continue on. Now you'd have to do 4 more, right? 1 inch per every 2.54 centimeters twice. To get the centimeters to cancel. And then 1 foot per every 12 inches twice. To be left with feet times feet or feet squared. It's the same result. This is a little more elegant and a little quicker, but slightly more prone for error, and this just takes longer. But you take care of every unit each step along the way. Either way, gives you the same answer. Alright, we got one more to go here, and it seems like it's scary, but it's not. Not if you think in terms of kilograms is a mass and pounds is a mass. Meters is a length and feet is a length. Cents is money and dollar is money. Let's see. Second squared is a time squared. Hours squared is a time squared. So the idea here is you have to take care of each one of these one at a time within the context of doing your problem. Alright, so let's do just a unit analysis up here. Kilogram, meter per second, squared, dollars, going to pound, feet per hour squared, dollars. Well, clearly that's a one step. Second squared goes to minute squared, then to hour squared. Kilograms to grams, grams to pounds, right? Then finally, meters to centimeters to inches to feet. Now that looks sort of crazy, but if we just take care of these one type of unit at a time, it really is a simple problem when you think of it just that way. So kilograms and meters on the top, second squared, and cents on the bottom. Let's do the denominator first. Doesn't matter. You can do it either way. So let's take care of second squared to minute squared to hour squared. Okay. Seconds has to be on top, right, to get it to cancel. And minutes on the bottom. You know there's 60 seconds per 1 minute. we're going to square the whole deal. That's how we get second squared to cancel and leave us with minutes squared on the bottom. Minutes per hour, 60 per 1, but we're squaring that. So the 60 gets squared, the 1 squared, and there, 1 squared is still 1, so you never have to worry about that part. I've now converted the bottom to hours squared. Let's convert the bottom from, or the denominator from cents to dollars. Well, there's 100 cents in every $1. Okay, well look what my units are at the bottom now. Hours squared cents. Hours squared cents is what we want. Good so far. Now let's go kilograms to grams, grams to pounds. Since kilograms is at the top, we need kilograms on the bottom, grams on top. 1,000 grams per every 1 kilogram. That's your metric to metric conversion that you remember. And then your metric to English says 454 grams is found in every 1 pound. Grams cancel. We're left with pounds on the top. We only have one more to go. Meters to feet. And that's a 1, 2, 3 conversions. See if I can squeeze them in here. Meters on top, which means meters on the bottom. We're going to centimeters. There's 100 centimeters per 1 meter. Meters on the bottom, meters on top, cancel. Centimeters to inches. 2.54 centimeters for every 1 inch. Centimeters, cancel. And finally, inches to feet. 12 inches per every 1 foot. Inches, cancel. So what do we have left at the top with units? Everything cancels except for pounds and feet. So pounds, feet is on the numerator. Hours squared, dollars is at the bottom because everything else canceled. Good. Infinite, infinite, infinite number sig figs. This, we used 3. That's a measured conversion factor between a metric and English conversion. Infinite, 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 and infinite. And since we started with 2, we end up with 2. So all we got to do now is plug everything in correctly, which means 4 times 60 times 60 times 60 times 60 times 100 times 1,000 divided by 454 times 100 divided by 2.54 divided by 12. Okay, I get 3.7 times 10 to the 10th pound-feet per hour squared dollars. I dare you to look that one up on the conversion sheet. You're not going to find it. I also dare you to look that up on the internet. You're not going to find that either. The only way you can do this is by going through this process one step at a time. Alright, we got one more kind of unit in Chapter 2 and we'll be done. That's what we'll do next time.